So, have you ever wondered how data scientists can juggle just massive amounts of data? Well, today we're going to get our hands dirty and build our very first data structures using one of the most powerful tools in Python, NumPy. Let's get right into it.
Okay, let's start with a little thought experiment. Imagine you're not just dealing with, say, 10 or 100 numbers. Imagine you have millions or even billions of them, right? How would you even begin to process all of that in Python without your computer just grinding to a halt? And look, this isn't some abstract problem. It's a real challenge that people in data science deal with every single day. And that, right there, is where NumPy comes to the rescue. There's a reason why NumPy is considered the absolute foundation for doing anything with numbers in Python. It's incredibly fast, it's super efficient with memory, and it gives us this brand new thing called a NumPy array. Honestly, the best way to think about it is like a supercharged version of a standard Python list, but one that's specifically built for high-speed math. All right, time to roll up our sleeves. We're going to start with the most basic building block of them all, the one-dimensional array. If it helps, you can just picture it as a single row of numbers in a spreadsheet. It really is the foundation for everything else we're going to build. Making our first array is really as easy as 1, 2, 3. First, we've got to import the NumPy library so we can use it. Then we'll actually create the array. And finally, we'll print it out just to admire our work. Simple as that. First things first, we need to tell Python that we want to use NumPy, and we do that with this one line of code, import NumPy as NP. Now, that little as NP part, that's just a nickname, a shortcut that basically everyone in the data world uses. It just saves us from typing out the full word NumPy over and over again. And now for the main event. We're creating a variable, let's call it array_1D, and we're using that nparray function. See how we just pass a regular old Python list right into it? You can think of this like taking a normal family car and dropping a Formula One engine inside. NumPy takes that simple list and completely transforms it into a seriously powerful array. And there it is. When we print it out, this is what we see. Notice anything? Look closely. There are no commas between the numbers. That's actually our first big clue that this is not a regular Python list anymore. Something fundamental has changed under the hood. So, we've built this thing. It looks a little different. But what is it exactly? All right, let's pop the hood and take a closer look at the engine to really understand what makes this new object so special. At this point, you're probably thinking, okay, I gave it a list. It kind of looks like a list. Is this just some fancy, glorified version of a list? And that is the perfect question to ask. The answer, though, is a hard no. It's something else entirely. Let me show you why. You know, when you just look at the code, creating a list and a NumPy array, they look almost identical, don't they? But that little np.array function, that's where all the magic happens. It's not just making a copy. It's completely re-engineering how that data is stored in your computer's memory. So, how do we prove it's something totally new? Well, we can use Python's built-in type function. Think of it like a DNA test for your variables. You give it your object, and it tells you exactly what species it belongs to. It's going to reveal its true identity. And there are the results. It's a numpy.nd array. That n just stands for n-dimensional. It's a fancy way of saying it can have any number of dimensions, 1, 2, 10, whatever you need. This nd array object, this is the heart and soul of NumPy. It's the reason it's so incredibly fast. Okay, so if it's an n-dimensional array, how many dimensions do you think our little creation has? We can check that easily. We just use the .indim attribute, which stands for number of dimensions. And the output is 1. There you have it. We have officially built our first one-dimensional array. All right, we've nailed the basics. Feeling good? Now it's time to level up. We're going to take what we just learned and build something a bit more complex, a two-dimensional array. This is where things really start to get cool. You know, one of the best things about NumPy is that its logic is super consistent. To make a 1D array, we give it a list. So to make a 2D array, you guessed it, we just give it a list of lists. See the code? There's an outer set of brackets, and inside that, we have 2 more lists. Each of those inner lists is about to become a row in our new 2D array. And look at that. When we print it, NumPy is smart enough to format it for us in this really clean, grid-like structure. You can instantly see the 2 rows and the 4 columns. We've just turned a messy list of lists into a beautiful, structured table of data. So now that we're building these more complex structures, we need a few more inspection tools in our belt. Think of what's coming next as the spec sheet for our arrays. It's going to give us all the important technical details we need to know at a glance. So let's just visualize our 2D array like this for a second, as a simple table. We've got 2 rows, 4 columns. Just lock that image in your head, because it's going to make our next tool make perfect sense. This is one of my favorite and most used tools in NumPy, the dot shape attribute. It tells you the exact dimensions of your array. And in this case, it gives us 2, 4, which, no surprise, matches the 2 rows and 4 columns we just saw. It's such a quick way to understand the structure of any data you're working with. Now, what if you don't care about the rows and columns? You just want to know the total number of items in there. For that, we have the dot size attribute. It's just a handy little property that gives you the total count instantly. And of course, 2 times 4 is 8, so our array has a size of 8. And for our final inspection tool, we need to know what kind of data is actually inside our array. The .dtype attribute, which is short for data type, tells us we're working with int 32, or 32-bit integers. And this is so important because a NumPy array can only hold one single type of data. Now, that might sound like a limitation, but it's actually its greatest strength. By forcing everything to be the same type, NumPy can do its calculations way faster than a normal Python list ever could. And that's it. A huge congratulations! You have now built and inspected your first 1D and 2D NumPy arrays. That's a huge leap in a very short amount of time. So let's just do a super quick recap of the essential tools you've just added to your data science toolkit. These 4 attributes right here are your bread and butter when you're working with NumPy. You've got .ndim to tell you how many dimensions you have. You've got .shape to see the size of each of those dimensions. .size gives you the grand total of elements, and .dtype tells you what kind of stuff is inside. If you can remember these 4, you'll be able to understand pretty much any NumPy array that comes your way. You've just taken your first, and honestly, most important step into the huge world of data science. You now have the power to create and to understand the single most fundamental data structure in the entire Python ecosystem. The building blocks are literally in your hands. So the only question left is, what are you going to build with them?